question is, well, what the heck is an exponential function, right? What's an exponential function? What does it look like? Why is it called all this stuff? So here's an example. Here is an example of an exponential function. It's I'm going to say y equals 2 to the x. Why is it called an exponential function? Because the variable's in the exponent. Math people are not creative, right? As far as like terminology, this is called the exponent. All right, and this is called the base, but I think we already knew that, right? And what I'm interested in right now is, what does this graph look like? And anytime a teacher puts a new graph on the board to figure out what it looks like, you make an XY chart. So I'm going to make an XY chart. So here's my X, here's my Y chart, and I get to pick any values I want, and my favorite ones are usually -2, -1, 0, 1, and 2. Okay? Let's just figure out where these Y values are. So let's plug the easy one in first. I'm going to plug 0 in. Well, that means I plug a 0 in for X, and so what's 2 to the 0? Anything to the 0 power is? 1. When I plug a 1 in, what's 2 to the first? 2. We're getting there, all right? When I plug a 2 in, what's 2 squared? 4. All right. You know what? While I'm at it, I'll go ahead and plug a 3 in. When I plug a 3 in, what do I get? 8, because we get 2 cubed. Everybody okay with this? So if I'm interested, so I've got these numbers. So let's find out what my exponential graph is doing. At 0, I'm at 1. At 1, I'm at 2. At 2, I'm at 4. At 3, I'm at 8. And what you may start noticing is if you were to connect these dots, this graph is getting very steep very quickly, right? In fact, if I were to plot one more point, let's say I were to plot the point 4, that would be 416, which is, somewhere up here. I already have a dot. Okay? Right? And also, if you've ever heard of the phrase something is growing exponentially, that usually refers to things that are growing very quickly. What they're really doing is describing the steepness of this graph. Do you see that the further to the right you go, the steeper it gets? And the steeper a graph is means it's changing quickly, right? So when they talk about exponential growth, they're talking about something that's getting very big very quickly. In fact, exponential growth is one of the faster growing functions that we have in math. All right, well, enough of the right-hand side. Let's deal with the left-hand side. Let's plug a -1 in. And so that's 2 to the -1. So what's 2 to the -1 going to be? 1 over 2, right? Negative exponent, that's in the wrong spot. And so that's 1 over 2. All right, well, what happens if I plug a -2 in? What do I get? 1 over 4. All right, so that gives me 1 over 4. Actually, while I'm at it, I'm going to go ahead and plug a -3 in. And what do I get?
1 over 8.
Are we okay with 1 over 8? So now I'm going to plot those points. So at -1 I'm at a half, -2 I'm at a fourth, -3 out of an eighth. So I'm going down. Do I ever get down here? What would have to happen for me to get down here? My y values would have to be negative. Are my y values ever going to be negative? No, because a negative exponent just gives me a fraction, doesn't it? It doesn't make the things negative. And so what ends up happening is I just get closer and closer to 0, the further to the left that I go. And so when I draw this, you know what? Don't try to say that you're getting closer and closer to 0. It's not going to happen. Just go ahead and draw the line and just draw it on the x-axis. Don't try to leave any space, right? That's where people mess up. Don't try to leave any space. It just goes down. Well, let's see. So we've got our lovely exponential graph. And anytime a math teacher gives you a new graph, they always want to talk about domain and range. So let's talk about domain and range. What's my domain of this? How far left and right does it go? How far left does it go? All the way. How far right does it go? All the way, right? It goes all the way up, but it goes all the way to the right. Does that make sense? So my domain's going to be from negative infinity to positive infinity. All right, let's talk about range. How low does this go? You can. It's got y values. What's the smallest y value you get? Right above 0. Does it ever equal 0? No. So the smallest it gets is 0. How high does it go? All the way up. And so my range goes from 0 to infinity. Does that part make sense? We okay with domain and range? All right. So before we get to kind of the main part of today, I'm going to talk about other exponential functions. All right? I like dealing with an exponential function of base 2. The reason I like dealing with base 2, the numbers are manageable. Right? There are other exponential functions. You could have 3 to the x, 4 to the x, 5 to the x, 10 to the x. Right? Now, the good news is they all have basically the same shape. Right? But I don't want you to take my word for it. I want you to take the computer's word for it. So first, this is 2 to the x. Everybody okay? I mean, I had enough dots. I got a pretty accurate picture. Let's look at 3 to the x. So let's plot that function. Some things about plotting 3 to the x. I just want to make sure there are some important aspects of all exponential functions. First, that one aspect. Notice how it's getting close to the x-axis. This is, remember, did we have a situation where we graph things that got close to a line? What was that special line called? An asymptote, right? So exponential functions have an asymptote. What can you tell me about the asymptote of the asymptote of 2 to the x and 3 to the x? It's 0. They're both the same, right? Do you also notice that both exponential functions cross at this one point, right? That one point I'm going to make a big deal about in a little bit. I actually call it the special point, right? But there's something significant about it, and we'll talk about the significance of that in a little bit, right? And for the most part, the graph of 2 to the x and 3 to the x, they're pretty similar, aren't they? They both start flat, they hit the special point, and they curve up. Now, the 3 to the x curves up a lot faster than the 2 to the x, but they still curve up, don't they? Right? All right, now let's see what 4 to the x looks like. Oh, look at that. 4 to the x still has that horizontal, has that asymptote at 0, right? It still goes through that special point, but guess what? 4 to the x is a little bit steeper still, isn't it? Based on this information, what do you think the graph of 5 to the x is going to look like? Kind of the same thing, isn't it? Except even steeper, right? And so let's see if that's what happens. So let's plot our function, and voila, yes, there it is. And it turns out all exponential functions have this basic shape. And right now, my main goal today is that you understand the basic shape of an exponential function. Right? That's my main goal, right? So, how do you graph? What we're about to do is we're going to graph exponential functions. And what I need... Excuse me. Oh, boy, sneezing with a mask on is way more complicated than... Yeah, sneezing this year is harder than last year. I've been telling you about that drinking problem. I mean, you got... Oh, I recorded that. That probably shouldn't have done that. All right, so before we actually get into the real part of today's lesson, I want to talk about how you graph an exponential function. Like, if I say graph a parabola, everybody in here knows how to graph a parabola, right? And the most important part of a parabola is the vertex. Like, if I ask you to graph a parabola, your first thing is, where's the vertex? Get the vertex, and then I put the little u either up or down, depending on everything else, right? Same thing with the absolute value. You get your v. Okay, where does the v go, right? There's all these lately. So what's important about an exponential function? Well, there's two things that are important, and I want to emphasize that right now. So even if you don't take notes, I need everybody to have a sheet of paper and you can write write something, right? This is not official notes. I just need you to write something down. And what I want you to do, the first thing I want you, you're drawing. You're not even writing words. What I want everyone to do is draw a horizontal line. A dashed horizontal line. This is going to be your asymptote. It doesn't have to go over the whole sheet of the paper, right? I just need something, right? Now, I want everyone to put a dot. This is your special point, and roughly I want you to put your dot, I want you to put your dot above your asymptote. Okay, does everybody have an asymptote and a dot? All right? Now, with the asymptote and the dot, we are going to draw an exponential function, and here's how you're going to draw it. Exponential functions, they start flat, they stay flat, they hit the special point, and then they curve up, and then they curve away. So everybody's got an asymptote and a special point. So I want you to put your pencil on the asymptote, hang with the asymptote until you get to the special dot, and then once you hit the special dot, you curve up. Right? Is everybody drawing that? You have now drawn your first exponential function. Right? Like with a parabola, you know what to do, right? A parabola, okay, I'm going to draw, actually, I should have. That was not as nice as it should have been. Hits the special point and then starts curving up, okay? So, like all the other functions you've graphed, it's like you know what to focus on. An exponential function today, this is the first day, you don't know what to focus on, and so the way I'm trying to get you, tell you what to focus on is the asymptote and this special point. And with an asymptote and a special point, you can draw your exponential function. Does that part make sense? Right? Everybody got it? So, now let's go into actually drawing. Let's go through. Oh, wait, I need to delete some stuff. That's way too confusing. Okay, so this stuff needs to go away. I'll leave the original up there. All right, so first problem. I want to graph y is equal to 2 to the x minus 3. And that minus 3 is here. All right, what does that minus 3 do? What does it do to the graph? Moves it down 3.
It moves the asymptote and the special point down.
Everything moves down 3, right? It takes the entire graph and moves it down 3. So how do we draw this picture, right? And how you draw an exponential function, it's the same thing every time. The first thing you're concerned about is, where's your asymptote? All right? So where is your asymptote? So if it's negative 3, right? If our original asymptote started at 0, if I move it down 3, where's my new asymptote going to be? It's going to be at negative 3. Is everybody okay with that? Now to graph an exponential function, I need the asymptote and I need a special point. How do you find the special point? Well, right now, your special point is 1 away from the asymptote. So notice how here the original asymptote was here and our special point was 1 away. So if I have my asymptote sitting here, my special point is going to be 1 away here. Are we okay with the asymptote and the special point? And now that you've got the asymptote and the special point, can you draw your exponential function? All right? So we put our pencil on the asymptote, it sort of hangs there until you get to the special point, and then you curve up.
It doesn't matter where you start on the asymptote.
Not really, no. I'm not being super precise here, right? I mean, technically, because the problems I'm going to give you in Khan Academy, they're going to ask for the asymptote, the special point, and then one other point. Technically, that one other point is 2 away from the asymptote. So when I guess if I were going to be a little more precise, I'd better make sure I go through that that's 2 away. Okay. But right now, I'm all about what does this, how do you graph? Or Are we okay with that's what the minus 3 does? All right. Well, what if I gave you y equals 2 to the x minus 1 plus 2? See what this graph looks like. Okay. All right, so if I want to graph this red thing, I'm interested in where's my horizontal asymptote. So where's your horizontal asymptote? 2. And here's the big secret. When you're graphing exponential functions, whatever this number is, that's where your asymptote is. So I have a horizontal asymptote at 2. So I draw my horizontal asymptote at 2. I have a special point. That special point is 1 away. But what does that minus 1 tell me to do? Go to the right one, right? Because it's inside. Everybody see that's inside? And so I'm going to go to the right one. So I have my asymptote, I have my special point. Do I have enough information so I can draw my picture? Because we know how to graph that. We put our pencil on the asymptote, we draw, we hit our special point, and then we go up. Does that make sense? Do you see how all that stuff that we did with transformations, the rules haven't changed, have they? The only thing that's different is how do we draw this exponential function, right?
Did you include the base also, or are we just ignoring the base?
Every problem I'm giving you, or at least the ones in homework, are all going to be a base 2. Some of the ones in Khan Academy are going to have different bases, like I think one's a base 2, one's a base 3.
Will it like determine where the graph is though?
It doesn't change where the special point is, and it doesn't change where the asymptote or the special point is. What it does change is where we cross, right? And so this particular one, this is actually going to cross well, that's weird. Yeah, actually, no. I'll talk about how it crosses later, right? But right now, I'm basically, how do you deal with, you've got an exponential function. What I want you to focus on is where's my asymptote, where's my special point, right? And then sort of where do you draw the sweep? Are we okay with the translations? How do we find our asymptote? How do we find our special point? All right. Well, now, what does this look like? What if I give you y is equal to a negative 2 to the x? What does that negative do? What did it do last week when I made you do all those problems? What did the negative on the outside do? It flips it down, right? Everybody okay with that? So, when you see a negative, okay, somehow we have to flip our graph. How do we flip our graph? First, the negative here doesn't change the asymptote. So our asymptote's still at 0. What that negative does is it changes where your special point is. I don't know if you noticed, but when I talked about the special point, I always described it as being 1 away. I didn't say 1 above, right? Because if it's above or below is determined by whatever this is. And since this is a minus, that means our special point is 1 below. Right? We still have our asymptote, we still have our special point, but now when we have a negative, we make sure we put our special point below the asymptote. And so here's our asymptote. So to graph this, we put our pencil on this, and then we curve down. So I start here, I hit the curve, and I go down. And does it look like this graph has been flipped? All right. So your turn. I want you to graph y is equal to a negative 2 to the x plus 3 plus 4.
Will the graph ever flip on the y-axis?
What would cause that?
A negative index, probably. But
You're on my next example. But good job.
Isn't that what it's like, it'd be like y negative 1 or something?
Just graph this. Where's your asymptote? That's easy, isn't it? Right? Is it easy to identify the asymptote? Right? So, is everyone drawing the asymptote? Put your special point, and then draw your swoop. Okay? So, everybody okay? The asymptote's at 4? Right? So the asymptote's at 4, so I draw my asymptote at 4. Okay. Is the special point above or below? Below, because there's a minus sign. What's the plus 3 tell me to do? Go left 3. Is everybody okay? We got our special point. We got our asymptote and our special point. And so now we draw. We start here. We stay on the asymptote. We get the special point, and then we sort of curve away. Does this make sense? And those of you that went through all of the torture with the transformations in Khan Academy, do you see how that just made your life a whole lot easier? Right? So, are we kind of okay with this part? Now, this next one, this is kind of interesting. Because I would like to know what the graph of 2 to the negative x is. Now, Jared's probably got a good idea, right? He's kind of thought about this. So you're like, hey, you got a negative next to the x. What happens when you have a negative next to the x? What happens to the graph? It flips this way, right? But you know what? I'm the teacher and kind of stubborn. I'm going to make an xy chart, right? So I'm going to make an xy chart, and so here's my xy chart, and I'm going to pick -2, -1, 0, 1, 2. And I'm going to plug 0 in. Are we okay that -0 is still 0, so 2 to the 0 is still 1? I'm going to plug a 1 in. That gives me 2 to the -1, which gives me 1/2. I'm going to plug a -2 in. That gives me 1/4. Are we okay with that? When I plug a -1, those cancel. That gives me a 2. When I plug a -2, those cancel. That gives me a 4. Right? And so I plot them. And let's see, at -2, I'm at 4. At -1, I'm at 2. And I'm here, and then I'm 1/2 and 4. And oh, look, it does what we thought it would do, right? First, did that change where my asymptote was? Right? Did this behave like we thought it would? Right? We have a negative next to the x, and when you have a negative next to the x, that means it's going to flip across the y-axis. Now, the reason I plotted those points wasn't just to generate this graph. Mostly because I'm crazy, right? Because what sane person would ever teach, right? No one would ever do that. But I'm also interested in, so I'm interested in the graph of 2 to the negative x. I'm also interested in the graph of y equals 1/2 to the x. Like, your bases don't always have to be greater than 1. Sometimes your bases are fractions, right? I have no clue what that thing looks like, so I'm going to make an xy chart. And I'll plug in the same values. I've got -2, -1, 0, 1, 2. Are we okay that 1/2 to the 0 is 1? If I plug a 1 in, that's going to give me 1/2. If I plug a 2 in, 1/2 squared is 1/4. If I plug a -1 in, let's see, 1/2 to the -1. What's 1/2 to the -1 going to be? Because the -1's flip it, right? And so that gives us a 2. And if I do 1/2 to the -2, okay, that's going to give me a 4. Huh. So what do you notice? What do you notice about the graph of 1/2 to the x and 2 to the negative x? They're the same. And my smart aleck response is, well, of course they're the same. What's a negative exponent mean? It's in the wrong spot, right? And so this gives me 1/2 to the x, which is the exact same thing as 1/2 to the x. Does that make sense? Okay? So if you have a negative next to the x, or you have a fraction raised to a power, they have the same picture. They've been flipped. Right? And you'll see examples of both of those. Right? But if we're graphing 1/2 raised to a power, do we see that the asymptote's the same? Do you see the special point's the same? The difference is how you draw it. Do you start flat from the left, or do you start flat from the right? Do you see that? Like the original problem is you start flat this way. Go flat, hit your special point, and go up. Whenever you have a fraction, you start flat on this side, hit your special point, and go away. Does that make sense? So, let's see what happens when we put all this together. Let's say I give you y is equal to 1/2 x minus 4 plus 2. Let's see what this graph looks like. First, where's the asymptote? Okay, is the asymptote easy to find? Okay, so we get our asymptote at 2. All right, is the special point above or below? Is it above or below the asymptote? Above, right? If this thing's positive, it's above, all right? So the special point's above. What's the minus 4 tell me to do? Go right 4, 1, 2, 3, 4, and put a dot. Are we okay that we've got our asymptote and we've got our special point? All that's left is to draw. Do I start flat on the left or start flat on the right? I start flat on the right, I stay with it, hit the special point, and go up.
So whenever it's a fraction, it's going to start from the right?
Yes. A fraction or a negative next to the x. Does this make sense? Is this consistent with all the transformation stuff I made you do before? Which is why I made you do it, right? Because I knew this was coming. Huh.
How do we know if it's going to be above or below?
If this is positive or negative. If
Okay.
this thing is positive, you're above. If this thing's negative, you're below. All right? We kind of okay? All right.
Do you just want the special point? Do you not want any other points?
Graphing by hand right now, I just want the special point. Khan Academy is going to force you to actually put some other point, one additional point in. Like for this one, Khan Academy wouldn't, like you've got to have the asymptote and the special point, but you also need an additional point. And if the base has something to do with 2, your next point has to be 2 away. So I guess I should have been a little more precise in graphing this, in that it's got to be 2 away, so it's going to include that dot. And so it's going to hit here, and it's going to do the special point. What's the why is it 2 away? Because this is a 2. If this was a 3, it would be 3 away. All right. So I've talked about moving things left, right, up, down. I've talked about flipping up and down, flipping left and right. What I haven't talked about is dilations. All right? So that's next up. What if I give you y is equal to 3 times 2 to the x? How do you graph that? Right? How does that change the graph? First, can we agree it's going to change the graph? How? When you multiply by 3, how does it change it? It pulls it, right? It stretches the sheet of paper. When you stretch the sheet of paper, what it's going to do, normally the special point is 1 away from the asymptote. If this is getting stretched by a factor of 3, it is now, the special point is now 3 away. So the way this is graphed is this is now 3 away. The asymptote's still here. But now when I graph, I stay here, I hit my special point, and then I go up. Does that make sense? Everybody understand that part? Ah, good. Here, let's do one more, and then I'll let you start your Khan Academy stuff. So, let's do y is equal to a -3 times 2 the x plus 1 plus 5. Where's the asymptote? 5. That's easy, right? So the asymptote's at 5. Oh, I should probably keep it color coded. Is the special point above or below? It's below. How far below? 3. 1, 2, 3. Okay, so I've got the asymptote, I've got my special point. Do I start flat on the left or start flat on the right?
Don't you move the special?
Oh, I have to move the special point. Which way?
Left hand.
I gotta move it left. Thank you. So now that we've got our special point and our asymptote, where do we start? Do we start on the left or start on the right?
Right. Well,
Why did you have to move the point to the left?
So what?
Oh, okay.
What? You're gonna start on the left. What would have to happen if we started on the right? It'd either be a fraction or there'd be a negative next to the x. So we're gonna start here. And then once you do this, the rest is easy, isn't it? You start here, hit your special point, and go away. Does this make sense? All right, so